Okay, before I start next lecture, I would like to do some correction on the previous video. I think it's video number 4, which is when I think is yes, 1 2 3 4. Yep, video number 4. Okay, when I discuss about the how I change my code from the simple ANN into this other AAN that I give you for group activities. So how actually I generate the code based on simple AN code. And then the one that I missed to discuss is about if you refer to the architecture of your design here. Okay, there's no bias. Okay, you realize that there's no bias, meaning that your bias is equal to 0. Okay, so in other words, if you have this kind of architecture where there's no bias, then you can conclude that the bias is equal to 0, or in other words, actually it should be, there's a bias there, still there's a bias. This one is B1, but the input for this bias is 0. Okay, so this one is also 0, this one is B2, and then this one you have a B3, and you inject with 0, and then same goes to this one, B4, you inject with 0. So means that if this is the architecture, you can if you do the hand calculation, of course you can't ignore this error. Okay, or ignore this arrow there. Means that if you don't draw at all, it's okay, because this does not affect at all in your architectures there, or in your hand calculation, because even if you include that one in calculation, the B there is not give anything for your hand calculation. So you just, for example, to find the O2 here, I mean the O1 here, O1 2, then you just can multiply between the W and the X there. Okay, so don't have to put the plus B there, because B there, because the B is multiplied with 0, that's why it can be cancelled out there. The equation is just leave it like this, means that O1 is equal to W multiplied with X. Okay, so if you refer to my code there, because my code there is consider as well as the bias, so I don't ignore the bias, so it's not represent the one that you draw in this slide. So that's why that will make you a little bit confused on because my code there, I don't ignore the bias, meaning that the bias is exists, means that here it should be there's a bias there. Okay, there should be bias there. Okay, in my code there, I don't ignore the bias, so it should be 1 bias B1 layer number 2, so there's a bias there, because I don't ignore the bias. So let's say I want to design the code which is represent this architecture, means that I ignore the bias. How I modify that? Okay, that is one to do. In order to do that, you need to do some major modification on your code there, meaning that you need first, okay, this is the previous code there, then you need to delete all the bias variables, or the variable represent the bias B2 and B3, you need to delete. Okay, you need to delete, and then even in this function you need to delete all B2 and B3, because we don't have that one. Okay, you don't have that one. Okay, same goes to this one, you need to delete the B there, B2 and B3. Okay, so And same goes to the back propagation function there. You need to do a modification. Of course, after you try this example, make sure that you undo back your code, because otherwise if you delete all this one, then the simple AN will not work properly, because this one need to use the B2 and B3. So if I delete this one, then the back propagation, when you call the function of back propagation at this simple AN.M, it will get you will get errors there. So make sure that you undo. Okay, I just show you the example. If I delete the B, all the B inside this function, because we ignore the bias. Okay, we ignore the bias, and then you delete this one, you delete this one. Yep. Okay, this one also you need to delete, because we don't have any, we don't update the bias anymore. We just update the W. Okay, let's save it and try to run this one. Okay, now we have the the code that represent these architectures here without any bias. So we see whether it can be run or not. Okay, I run it, try to run it. Yep, you can see that the result is okay. The result is almost similar with the one that we ran before. Okay, with bias. Even without bias, you still can get a result which is close to the actual result, which is this one. Okay, so I hope you clear about that.